Problem number 16 on the Part 1 review. Solve using the quadratic formula. X equals minus b plus or minus b squared minus 4 times a times c. That would be a minus 36, all divided by 2a. That would be minus 4 plus or minus the square root of, minus and minus would make that a plus, so 52 divided by 6. We're going to go over here on the side and do a birthday cake for the 52. And so 52 is going to be minus 4 plus or minus a pair of 2's with a 13 left over. There's one final thing you can do. 4, 2, and 6 have a GCF of 2. Divide this by 2. Divide 2 by 2 and cancels out. Divide 6 by 2. That is your final answer. Then we have problem number 17. Before I can solve it using the quadratic formula, I have to subtract 17 from both sides. And so then that would be x equals minus b plus or minus b squared minus 4 times a times c all divided by 2a. So that would be x equals minus 6 plus or minus the square root of 104 divided by 2. So I come over here on the side and do a birthday cake. So we're going to 52. There's a pair of 2's. So this is going to be x equals negative 6. Negative 6, 2, and 2 have a GCF of 2. Divide that by 2. Divide that by 2, it cancels out. Divide that by 2, and it cancels out. So there is your final answer. Roots, another name would be x-intercepts. Solutions. Zeros. It doesn't matter the order that you write those down. So for this graph right here, if I try to put it in a box, it keeps going that way, it keeps going that way. And interval notation, in inequality notation, you must start with the x. In interval notation, one, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This has a parentheses because this is an open circle. 1, 2, 3. 1, 2, 3, 4, 5. The next one has a typo. The y less than should be on this side of the page. You can graph this in your calculator and look at it. I have graphed it with a graphing program, and this is what it looks like. I have also graphed all of those points. All of the points are in the shaded area. All of the points are in the shaded area of the graph. Yes, all of these are solution points. To find the distance, the easiest way is to make this into a right triangle. This would be 2. And this would be a squared plus b squared equals c squared. This would be a 40 equals c squared. Take the square root of both sides. Do a box problem on the 40. Have a pair of 2's, so that c is equal to a pair of 2's. The 2 times the 5 makes a 10. This would be 2 square roots of 10 for the distance. And problem number 25, this is the distance it's talking about. You can make it into a right triangle. 1, 2, 3, 4. So 4 squared plus 8 squared equals c squared. $80 equals c squared. You would take the square root of both sides and do a box problem on 80. A pair of 2's and another pair of 2's and 5 left over. A pair of 2's and another pair of 2's and a 5 left over makes this distance 4 square roots of 5. This tells me to put function f equal to function h. This is a quadratic because x is squared. I need to have it equal to 0 in order to solve it. The factors of 9 are 1 and 9, 3 and 3, negative 1, negative 9, negative 3, negative 3. This is the pair I need. Since this is equal to 1, it will factor into. This is not the answer yet. Solve those equations. These are the two values that make these two functions equal.